Hello students, I am Ashwin Thakar from HA School, Pimpri, managed by DE Society. Students, in the previous lecture, we have seen the physical properties of metals, the physical properties of non-metals, then we have seen the chemical properties of metals, reactivity series of metals. Now, today we are going to see the chemical properties of non-metals. After that, we are going to see what are ionic compounds, and lastly, we are going to see metallurgy and its various concepts. Chemical properties of nonmetals. Reactions of metals with oxygen. Nonmetals combine with oxygen to form acidic oxides or neutral oxides. Carbon reacts with oxygen to give carbon dioxide. Reaction C plus O2 gives CO2, which is acidic in nature. In some cases, carbon reacts with carbon monoxide. Reaction 2C plus O2 gives 2CO, that is neutral. Sulfur reacts with oxygen to give sulfur dioxide. Reaction S plus O2 gives SO2, which is acidic in nature. Let us see this video.
Reaction of nonmetals with oxygen. Place a small piece of phosphorus on a china dish. Burn the phosphorus with the help of a glowing splinter. Cover it with an inverted gas jar. You will observe that the gas jar gets filled with white fumes. Make the gas jar upright and pour some water into it and shake well. The white fumes dissolve in water. Now put a few drops of blue litmus solution into it. The color of the litmus changes to red. It shows that the oxide of phosphorus is acidic in nature. This experiment proves that non-metallic oxides are acidic in nature.
Reaction of nonmetals with water. Generally, nonmetals do not react with water. Halogens react with water. Chlorine, on dissolving in water, gives hydrochloric acid and hydrochlorous acid. Reaction Cl2 gas plus H2O liquid gives HOCl aqua plus HCl aqua. Reaction of dilute acids with nonmetals. Generally, nonmetals do not react with dilute acids. Halogens, being a nonmetals, react with dilute acid. Chlorine reacts with dilute hydrobromic acid to give hydrochloric acid and bromine. Reaction Cl2 gas plus 2 HBr aqua gives 2 HCl aqua plus Br2 aqua. Reaction of nonmetals with hydrogen. Nonmetals reacts with hydrogen under proper pressure, temperature and catalyst. Sulfur reacts with hydrogen to give hydrogen sulfide. Reaction S plus H2 gives H2S. N2 plus 3H2 gives 2NH3. Students, now let us see what are ionic compounds. In the previous reaction, we have seen the reaction of metals with nonmetals. When metals react with nonmetals, they give ionic compounds. The cations are electropositively charged and anions are electronegatively charged particles. The electrostatic force of attraction between oppositely charged cations and anions is called an ionic bond. The compounds formed from cations and anions are called ionic compounds. Straight away, in the reaction of sodium and chlorine, the ionic compound NaCl is formed. Let us go through the properties of ionic compounds. First, they are electrically neutral. Generally, all ionic compounds are electrically neutral. Ionic compounds are strong bonds, so ionic compounds exist in solid state and are hard and brittle. Third property, due to high intermolecular force of attraction, they have high melting and boiling points. Next, they are crystalline in nature due to regular arrangements of ions. Fifth property, they are water soluble. Ionic compounds cannot conduct electricity in solid state but can conduct it in the fused or molten state, or even they get dissolved in some solvent. So they are called electrolytes. On the right side, you can see a picture in which different ionic compounds and their melting and boiling points are shown. Metallurgy. Science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. Occurrence of metals. Few metals occurs in the free state in nature. Example, gold, silver, platinum. Most metals in nature do not occur in the free state, but they occur in the combined state. Example, they are in the states of oxides, carbonates, sulfides, and nitrides. The compounds of metals that occur in nature along with the impurities are called minerals. The minerals from which the metal can be separated economically are called ores. Impurities in the ores are called gangue, which have to be removed. Basic principles of metallurgy. First principle, concentration of ores. The ores are concentrated in order to acquire the metals from them. The process of separating gangue from the ores is called concentration of ores. In this process, the concentration of the compound of the desired metal is increased. Concentration process depends on, first, the physical properties of metal and the physical property of gangue. Also, the concentration depends on the reactivity of the metal. Concentration of ore based on gravitation. Heavy particles of ores are separated from the light particles of gangue by gravitational method. First method is Wilfley's table method. On the right side, you can see the diagram showing the Wilfley's table method. In this method of separation, the Wilfley's table method is made by fixing narrow and thin wooden riffles on inclined surface. The table is kept vibrating continuously. Powdered ore obtained from the lumps of the ore using ball mills is poured on the table, and a stream of water is also released from the upper side. As a result, the lighter gangue particles are carried away along with the flowing water, while the heavier particles, in which the proportion of minerals, the table is kept vibrating continuously. Powdered ore obtained from the lumps of the ore using ball mill is poured on the table, and a stream of water is also released from the upper side. As a result, the lighter gangue particles are carried away along with the flowing water, while the heavier particles, in which the proportion of mineral is more and proportion of gangue is less, are blocked by the wooden riffles and get collected on the slit between them. Second, hydraulic separation method. On the right side, you can see the diagram showing hydraulic separation method. The hydraulic separation method is based on the working of a mill. There is a tapering similar to that used in the grinding mill. It opens in a tank-like container that is tapering on the lower side. The tank has outer outlet for water on the upper side and water inlet on the lower side. Finely grounded ore is released in the tank. A forceful jet of water is introduced in the tank from the lower side. Gangue particles are lighter and therefore they flow out along with the water jet and from the outlet on the upper side of the tank and get collected separately. At the same time, the heavy particles of the ores are collected at the bottom from the lower side of the tank. In short, this method is based on the law of gravitation, wherein the particles of the same size are separated by their weight with the help of water. Magnetic separation method. This method requires an electromagnetic machine. The main parts of this machine are two types of iron rollers and the conveyor belt moving continuously around them. This picture can be seen at the lower side. One of the rollers is non-magnetic while the other is electromagnetic. The conveyor belt moving around the rollers, which are non-magnetic, are made up of leather or brass. The powdered ore is poured on the conveyor belt near the non-magnetic roller. The two collector vessels are placed below the magnetic roller. The particles of the non-magnetic part is in the ore are not attracted towards the magnetic roller. Therefore, they are carried further along the belt and fall in the collector vessel. Vessel placed is away from the magnetic roller. At the same time, the particles of the magnetic ingredients of the iron ore stick to the magnetic roller and therefore fall in the collector vessel near the magnetic roller. In this way, the magnetic and the non-magnetic ingredients in the ore can be separated depending on their magnetic nature. For example, the cassiterite is a tin ore. It contains mainly the non-magnetic ingredients stannic oxide SnO2 and the magnetic ingredient ferrous tungstate FeWO4. These are separated by electromagnetic method. Next is the froth flotation method. The froth flotation method is based on the two opposite properties, hydrophilic and hydrophobic of the particles. Here, the particles of the metal sulfides, due to their hydrophobic property, get wetted mainly with oil, while due to the hydrophilic property, the gangue particles get wetted with water. By using these properties, the certain ores are concentrated by froth flotation method. In this method, the finely grounded ore is put into a big tank containing ample amount of water. Certain vegetable oil such as pine oil, eucalyptus oil is added in the water for the formation of froth. The pressurized air is blown through the water. There is an agitator rotating around its axis in the center of the flotation tank. The agitator is used as per the requirement. Bubbles are formed due to the blown air. Due to agitation of foam is formed from oil. Water and air bubbles together due to the agitation. This foam rises to the surface of water and floats. That is why this method is called froth flotation process. Particles of certain sulfide ores float with the foam on water as they preferentially get wetted by the oil. For example, this method is used for concentration of zinc blende, that is ZnS, and copper pyrite CuFeS2. The next process is leaching. The first step in the extraction of the metal aluminum, gold, silver from these ores, is the method of leaching. In this method, the ore is soaked in a certain solution for a long time. The ore dissolves in that solution due to specific chemical reaction. The gangue, however, does not react and therefore does not dissolve in that solution. So it can be separated. For example, concentration of bauxite, the aluminium ore, is done by leaching method. Here, bauxite is soaked in aqueous NaOH or aqueous Na2CO3, which dissolves the main ingredient alumina in it. During the extraction of metals from their ores, metal is obtained from the cation of metals. In this process, the metal cation is to be reduced. How to bring about the reduction depends upon the reactivity of the metal. We have already learned about the reactivity series of metals. Extraction of metals. Extraction of reactive metals like aluminium. Extraction of reactive metals is done by electrolytic reduction process. Step 1. Extraction of aluminium. Bauxite is the main ore of aluminium. Bauxite is leached by NaOH solution. Reaction Al2O3 2H2 solid plus 2NaOH aqua gives 2NaAlO2 aqua plus 3H2 liquid. Aqueous sodium aluminate is then diluted by putting it in the water at 50 degrees Celsius. An aluminium hydroxide precipitate is formed. Reaction NaAlO2 plus 2H2 gives NaOH AlOH3, that is aluminium hydroxide. This aluminium hydroxide further gives aluminium oxide. Reaction 2AlOH thrice gives Al2O3 plus 3H2O. Step 2. Electrolytic reduction of alumina. In this method, the electrolysis of molten mixture of alumina is done by. In this method, the electrolysis of molten mixture of alumina is done in a steel tank. The tank has a graphite lining on the inner side. This lining does the work of cathode. A set of graphite rods dipped in the molten electrolyte works as anode. Cryolite Na3AlF6 and fluorspar CaF2 are added in the mixture to lower its melting point up to 1000 degrees Celsius. Aluminium is deposited on the cathode on passing electric current. Molten aluminium being heavier than the electrolyte, it is collected at the bottom of the tank. It is taken out from there from time to time. Oxygen gas is liberated at the anode. Anode reaction 2O2 minus gives O2 plus 2 plus 4 electrons. Cathode reaction Al3 plus 3 electrons gives Al liquid. The liberation of oxygen reacts with the anode to form carbon dioxide gas. The anode have to be changed from time to time as they get oxidized during the electrolysis of alumina. Extraction of moderately reactive metals. The metals in the middle of the reactivity series, such as iron, zinc, lead, copper, are moderately reactive. They occur in the form of their sulfide salts or carbonates. It is easier to obtain the metals from their oxides rather than sulfides or carbonates. Therefore, the sulfide ores are strongly heated in air to transform them into oxides. This process is called roasting. The carbonate ores are strongly heated in a limited supply of air to transform them into oxide. This process is called calcination. You can see the roasting of zinc and calcination of zinc in the reactions given. The zinc oxide so obtained is reduced to zinc by using suitable reductant such as carbon. Reaction ZnO plus C gives Zn plus CO gas. Apart from carbon, reactive metals such as sodium, calcium, aluminium are also used as a reducing agent for the reduction of metals oxides to obtain the metals. Reaction 3MnO2 plus 4Al gives 3Mn plus 2Al2O3 plus heat. Another reaction Fe2O3 plus 2Al gives 2Fe plus Al2O3 plus heat. Extraction of less reactive metals. The metals at the bottom of the reactivity series of metals are less reactive. That is why they are found in the free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2S. Copper is obtained from Cu2S ore just by heating it in air. Reaction 2Cus plus 3O2 gives 2Cu2O plus 2SO2. Next, 2Cu2O plus Cu2S gives 6Cu plus SO2 gas. Refining of metals. The metal obtained by the various reduction process described above are not very pure. They contain impurities. The impurities need to be separated to obtain the pure metals. Electrolysis method is used to obtain pure metals from the impure metals. Corrosion of metals. Corrosion is usually defined as the degradation of metals due to an electrochemical process. Examples of corrosion. First, rusting of iron. Iron reacts with moist air and a deposit of reddish substance Fe2O3 H2O is formed. This substance is called rust. Rusting of iron particles causes large financial loss. Thus, corrosion of iron, that is, rusting, is the big problem. Patination of copper. Carbon dioxide in moist air reacts with the surface of the copper vessel. Copper loses its luster due to the formation of greenish layer of copper carbonate, CuCO3, on its surface. This is called patination of copper. Blackening of silver. On exposure to air, silver particles turn blackish after some time. This is because of the layer of silver sulfide Ag2S formed by the reaction of silver with hydrogen sulfide in air. By oxidation of aluminium, a thin layer of aluminum oxide is formed on it. Prevention of corrosion. The various methods are used to protect metals from corrosion. Some of these methods are as follows. To fix a layer of some substance on the metal surface so that the contact of the metal with the moisture and oxygen in the air is prevented and no reaction would occur between them. To prevent the corrosion of metals by applying a layer of oil paint, grease, or varnish on their surface. For example, corrosion of iron can be prevented by this method. The method of painting is suitable for short time. If there is a scratch on the paint on the surface of the article, and if a small surface of the metal comes in contact with air, the process of rusting starts below the layer of the paint. Corrosion can be prevented by putting a layer of non-corrodable metal on a corrodable metal. This can be done in many ways. The first way of doing this is galvanizing. In this method, a thin layer of zinc is applied to prevent the corrosion of iron or steel. For example, shining iron nails, pins, etc. In this method, corrosion of zinc occurs first because zinc is more electropositive than iron. After a few rainy seasons, the zinc layer goes away and the inner iron gets exposed. Then iron starts rusting. The next process is tinning. In this method, a layer of molten tin is deposited on metals. We call this as kalhai. A greenish layer formed on the surface of a copper or brass vessel. This greenish layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all such damages. The next method is anodization. In this method, metals like copper, aluminium are coated with a thin, strong layer of their oxides by means of electrolysis. For this, the copper or aluminium articles is used as anode. As this oxide layer is strong and uniform all over the surface, it is useful for prevention of the corrosion of the metals. For example, when aluminium is anodized, a thin layer of aluminium oxide is formed. It obstructs the contact of the aluminium with oxygen and water. This prevents the further oxidation. This process can be further increased by making the oxide layer thicker during the anodization. The next method is electroplating. In this method, a less reactive metal is coated on a more reactive metal by electrolysis. Silver-plated spoons, gold-plated ornaments are the examples of electroplating. The next method is alloying. Majority of the metal substances used presently are in the form of alloys. The main intention behind this is to decrease the intensity of corrosion of metals. The homogeneous mixture formed by mixing a metal with other metals or non-metals in certain proportion is called alloy. For example, bronze is an alloy formed from 90% copper and 10% tin. Bronze statues do not get affected by the sun and rain. Stainless steel does not get stains with air or water and also does not rust. Stainless steel is an alloy made from 74% iron, 18% chromium, and 8% carbon. In recent times, various types of alloys are used for minting coins. Students, in this way, we have completed our chapter Metallurgy. Students, in this chapter, we have seen the physical properties of metals, the physical properties of non-metals. Then we saw the chemical properties of metals, the chemical properties of non-metals. After that, we have gone through the reactivity series of metals. Then we saw the ionic compounds, how they are formed and what are the properties of ionic compounds. And finally, we have seen what is metallurgy and we have seen the various concepts of metallurgy. In this way, we have finished our chapter Metallurgy. Thank you.